Good morning, everyone. So, in today's session, we'll be discussing about the most important concept of your deep learning, that is your recurrent neural networks. Yeah. Neural networks is classified into three types. One is artificial neural networks. Other one is convolutional neural networks, and the next one is about recurrent neural networks, which we'll be discussing in today's concept. So recurrent neural networks is one of the classification of neural network or type of neural network where the output from previous step are fed as input to the current step. So previous concepts we have seen about single layer feed forward, multi-layer feed forward networks, and some activation functions where back propagation can be done using your back propagation algorithm. So that's how we have seen many concepts which can be applied for n number of use cases, but those concepts have some limitations which cannot be applied for some areas where you need sequential processing. That's the reason recurrent neural networks was developed, and this concept is mainly linked to your sequential data processing. That is, whenever you are having some data, uh, if you want to display your data as output from the previous steps, then you can use your recurrent neural networks. That's why the name itself is saying that it's a recurrent neural network, which means it recurrently or recursively computes the network, and it takes inputs from the previous step and provides some external output. Okay, so in traditional neural networks, that is your ANN and CNN, all the inputs and outputs are independent of each other. So whatever the input you're going to give, there will be a hidden layer which processes according to the weights and during according to the activation function, and it may lead to some output. So it cannot come back and talk about take the previous data as input from whatever the output it wants to give. That's the reason it has some limitations. So, but in cases like when it is required to predict the next word of a sentence, the previous words are required, and hence there is a need to remember the previous words. So, the main drawback of these previous mechanisms is that there is no memory for that networks, and it cannot remember the previous steps. That's the one of the major drawback of existing networks. And RNN tries to overcome this concept. That is, it will try to remember the previously happened things, and accordingly it will be giving some exact outcome. Thus RNN came into existence, which solved this issue with the help of a hidden layer. So the hidden layer in RNN is very important concept. It is a bit different when compared with the previous concepts. Okay, the main and most important feature of RNN is the hidden state, which remembers some information about a sequence. That's what we are discussing, guys. So here, hidden layer will try to remember the previously completed concept. It will try to store the information of the previous step, and whenever RNN or the output layer requires this information, it will try to provide the information, and accordingly the next step can be predicted. So predictions can be made possible using your RNN, which cannot be done using your existing mechanisms. Okay, so yeah, RNN have a memory which remembers all information about what has been calculated. So this is what is the important feature. RNN tries to store information or the previous step or data using a memory. So here it will be having a memory which will remember all the information about the previous calculations and the previous steps. So it uses the same parameters for each input as it performs the same task on all inputs or the hidden layers to produce the output. So whenever some input is provided, and if you want to get some appropriate output, RNN will rely on the previous inputs. So at every iteration or at every step, it uses the same parameters for each input being provided. So every time it backtracks, it will move backward, and it will try to get that information. So this is how it reduces the complexity of parameters, unlike the other neural networks. Okay, that are some of the important things which we need to make a point. Like, it will be having a memory and memory storage where it can keep tracking of the previous steps also. That is one important concept of your recurrent neural network. Okay, yeah. So let's get deep into this concept of recurrent neural networks. So here you can see the architectural representation of your recurrent neural networks. It is similar to your previous concepts of artificial neural network, but here you can see the recurrent nature of your data at different hidden layers. So here you can see you are having one hidden layer with two elements, and here you're having a hidden layer with three elements. So that's how a hidden layers plays a major role according to the inputs whatever you are having. So it recursively moves to the n number of times, it will be showing information, and accordingly it will be providing the class labels or the target variables. So what actually is this recurrent neural networks? Okay, so a recurrent neural network is a type of neural network that contains loops, comma, allowing information to be stored within the network. So this can be termed as the basic definition for your recurrent neural networks. So it allows information to be stored within the network. That is how, because it is having a small storage of your memory. So in short, recurrent neural networks use their reasoning from previous experiences to inform the upcoming events. So the information what is being stored can be taken forward to the next step using your recurrent neural networks from the hidden layers. That's the reason it is more feasible when compared to other neural networks. So recurrent neural network models are valuable in their ability to sequence vectors. As I said in the initial stage, it will be mostly used for sequential data processing. So which opens up the API to perform more complicated tasks. So whenever you are having some complicated task which needs some previous steps as input, then RNN gives you the appropriate solution. And there are some APIs being designed to perform this task, such as speech recognition or online translation of different languages. So these type of things can be performed using your recurrent neural networks. So everybody need to remember this architecture without any confusion. So this is similar to previous concepts, but here you can see the extra layer here, that is the network try to store some information at the hidden layers, and accordingly it will take from the previous steps. Okay, yeah. So recurrent neural networks are the concepts which are being developed in the years 1980s. So since 1980s, there was much contribution by many people in the area of this neural networks, and at that time only RNN also came into existence. So RNN takes input as a time series and a sequential data, and provides output also as a time series data. They have at least one connection cycle. So previously you can see the architecture, there is one connection cycle. Likewise, there can be a number of connection cycles in your recurrent neural network to process your data. So one of the biggest uniqueness or the advantage of these RNNs is it have universal approximation property, which means it can approximately approximate virtually and dynamical systems. So it's not only about one system it can be done; it approximates a number of things also. So this unique property forces us to say recurrent neural networks have something magical about them. So yeah, this property is not part of your artificial neural networks or other neural networks. So this is the only this is the unique property which RNN has, which forces us to say that recurrent neural networks have something magical. That's the reason it can give some approximations about the predictions about the next step, taking into consideration the previous steps. Okay, yeah. So this is in-depth architecture or a clear view of what RNN can do with respect to the understanding. Here you can see you're having one input layer, and you can see in hidden layers you are having a number of connections again here. So here, suppose assume that you are giving some input, and from this layer, information is passed to the output layer, but the information is again stored at the place, so that whenever there is a requirement to get back to that hidden layer and process the information, that can be done using your recurrent neural network. And here you can see the output can be stored and processed according to how a brain processes the information in human beings, which actually we do learning, right? So whenever an incident happens in our life or in our day-to-day situation, we try to remember the situation, and whenever we meet that situation we come to know that yeah, this situation already happened, so that we can remember. The same manner, RNN also try to store some information with respect to any input or calculations, and whenever the situation or the requirement comes, it will try to go back and get that information, and accordingly it will be using processing the information. So most of the organizations and research activities are now linked to your artificial intelligence with respect to your recurrent neural networks. So this concept is actually part of your deep learning concepts, but however it can be applied to your any artificial intelligence problem, which you'll be seeing in the next slides. So here you can see, yeah. So RNN is useful for the tasks that are dependent on a sequence of a successive states, right? So whenever they are having successive states where you need information from one stage to other stage, so this is very useful. RNN is much more useful here. Okay. So talking about your training, the network can be trained by back propagation. So yeah, as I said, you'll be having back propagation is allowed here used for your activation functions. So you will be having an algorithm linked to your recurrent neural network, that is your back propagation through time. That is an algorithm used for updating weights in the recurrent neural network to minimize the error of network outputs. So as we have discussed in the previous topics or previous sessions about your back propagation, the same manner back propagation through activation function is allowed in recurrent neural networks also, to process information from previous step to the next step. So for every recurrent network, there is a feed forward network with identical behavior. So it can process the feed forward network. It can also use your feed backward network. Thus, it can combine many networks, and accordingly, it can provide your outputs. And the next important observation to be understood is about memory concept, which is a unique property of these recurrent neural networks. So the network has a form of short-term memory. So we'll try to understand what is this short-term memory in the next slides when we are discussing about the concept of this RNN. And simplicity, it is simple recurrent network that has a similar form of short-term memory. So we will try to see how this memory is useful to understand the outputs of from the next step. And you can see there is one more thing, that is your back activation, which is the important concept of these recurrent neural networks. That is, a recurrent connection feeds back activation that will affect the output from the network during subsequent iterations. So whenever it is iterating a number of times, so according to the input, or according to the condition need to be specified, it iterates back a number of times, and accordingly it will be providing some outputs. That is one important thing to be observed with respect to your recurrent neural networks. Okay. So this is the architectural representation of your RNN, or recurrent neural networks. So you can use this architecture, or you can also use this one in your examinations to give answers accordingly. Okay. Yeah. So now talking about how this ANN is used in industry and also with respect to many areas. So the main use of these RNNs are when using Google or Facebook, these interfaces are able to predict the next word that you are able to type. So you can see whenever you are searching through Google or Facebook or some, they are getting some recommendations, right? So according to the previously searched transactions, suppose if you're opening your Google and typing what, or something, any keyword, it will try to automatically give some predictions about the word whatever you have typing. So depending on the word input whatever you have given, it will try to recommend you the next processing step. That can be done using your recurrent network, because the information is already stored in the network, and whenever you're going to type some approximation word, it will try to go back and search any relevant information, and accordingly it will try to provide the output. And also whenever you are using your Facebook search, if you are using your any alphabets or any words, suppose if you are searching your friend's name, once you type your one or two names, automatically the network whatever you are having, all those predictions will be available to you. That is also developed using your recurrent neural network concept only. Okay. So RNNs have loops to allow information to persist. That is, it will be looping its complete structure a number of times, and according to relevant information it will try to provide some approximate input. So this reduces the complexity of parameters, unlike other neural networks. So other neural networks like ANN and CNN might not be so appropriate when compared to your RNN. That's why RNN has much more prominence when compared with other concepts of your uh, neural networks. So these neural networks are considered to be fairly good for modeling sequence data. So from the initial style, we are discussing that this can be used for your sequential data processing or time series predictions. Okay, so recurrent neural networks are a linear architecture variant of recursive networks. So it is much similar to your recursive networks, but linearly it looks a bit different. Okay, so yeah, as I said, they have a memory, thus it differs from other neural networks. So whenever somebody asks you what's the difference between ANN or RNN or CNN and RNN has memory, which is a add-on feature. Thus it is much more efficient than the existing mechanisms. This memory remembers all the information about what has been calculated in the previous state. It uses the same parameters for each input, as it performs the same task on all the inputs or the hidden layers to produce the output. So the memory concept or the memory ideology here is a much important thing to be noted when learning about your recurrent neural networks. Okay. Yeah. So how actually this RNN works? So what is the working methodology of your recurrent neural networks? So recurrent neural networks can be thought of as a series of networks linked together. So here you can see the representation of your various understanding of your RNN. So you can see it can be one-to-one way of representation, that is input, hidden layer, and output. And here you can see one input, multiple hidden layers, and many outputs. So sometimes you may have multiple outputs also, among which you will be selecting a proper result. Suppose assume you are taking a Google search history, you are giving one input here with respect to the searching some keywords, and there can be a number of hidden layers which are able to continuously iterate and search relevant information with respect to that query, and it will be trying to provide you all the relevant information from the output. So accordingly, you'll be choosing the better output among all these things. Whichever is more useful to me, that output will be taken. That is called as one to many. And similarly, you'll be having many to one. You can provide a number of inputs, and according to that, it will be iterating in the hidden layers through the memory, and it may also provide you one approximate output, that is many to one. So also you'll be having many inputs and many outputs, many to many. Okay, that these are the examples of understanding of how this RNN works. So depending on the input being processed, it may process a number of hidden layers, and it may provide multiple outputs or also a single output. Okay, so a RNN can be designed to operate across sequence of vectors in the input, output, or both. For example, a sequenced input may take a sentence as an input and output a positive or negative sentiment value. So whenever you're going to give some input and asking whether it is a good or bad, you may get a comment whether it is good or bad. Alternatively, a sequenced output may take an image as an input and produce a sentence as an output. So whenever you are going to train any neural network, you will be providing inputs as image, and accordingly you may get some output which is linked to that image. That's how this neural networks works using your different way of modeling. Okay. Yeah. So now let's try to get into the concept with the example understanding of your RNN. So let's assume that you are training a recurrent neural network model, or you're developing a model, and you are given a task to load or train a model with a word called as happy. So now the task is, I want to make a neural network understand that happy is the word which I want to give to the network. So given, and I'm only giving the letters called as HAPY. So I'm only giving alphabets, 4 alphabets, and I want my RNN to train form a word called as happy. So if I want to form a word of such manner, how a RNN actually works. Okay, so the RNN will be trained on 4 separate examples, that is H, A, P, Y separately, each corresponding to the likelihood that letters will fall into an intended sequence. So basically the order may be varying. Sometimes it may look into ascending order or descending order, and according to the different order of the input being provided, it will be trying to see the likelihood of this arrangement. So for example, the network will be trained to understand the probability that the letter A should follow in the context of H. So according to the output here, output is happy word, which is in the order of H, then A, then P, P, and Y. So initially it will be trying to identify the search called as H. and once H letter is identified, it will try to check the probability of occurrence of A immediately after H. Similarly, the letter P should appear after sequence of HA, and also again a probability will be calculated for the letter P following the sequence of HAP. That's how it will look into all the probability calculations, and accordingly it will try to feed the network. This process will continue until probabilities are calculated to determine the likelihood of letters falling into the intended sequence. So according to the inputs of the intended sequence, it will try to look into all the probabilities until it reaches the likelihood. So as the network receives each input, it will determine the probability of the subsequent letter based on the probability of the previous letter or sequence. Okay, so this is how a RNN will be trained according to the given inputs. So over the time, network can be updated to more accurately produce results. So initially, it may take time to process the probabilities to understand the probabilities. But once the algorithm tries to learn from the behavior of this concept, in the upcoming stages, whenever you are providing such inputs, it may automatically try to understand the sequential flow, and it may provide some better results. That is the advantage of these artificial recurrent neural networks. Okay, yeah. So, yeah. So, as I said, the concept of recurrent neural network is basically a deep learning concept. So, a recurrent neural network is an artificial neural network used for deep learning. It can be used for machine learning, and it also forms or it can be useful for other forms of your artificial intelligence also. So they have a number of attributes that make them useful for tasks where data needs to be processed sequentially. So whenever you are having your sequential data processing, the by default choice of your neural networks is your recurrent neural networks. But training this recurrent neural networks is not a easy task. It needs a high end programming language, and also the understanding of the network knowledge. So to get a little more technical, recurrent neural networks are designed to learn a sequence of data by traversing a hidden state from one step of the sequence to the next, combined with the input and routing it back to the fourth between the inputs. So this is already discussed, like it will be having multiple inputs, or you may have single inputs, and according to the input provides, it will go back to the previous steps, and if required, it will try to take information from the previous steps, and it moves ahead with the that information. So RNNs are neural networks that are designed for the effective handling of sequential data, but are also useful for non-sequential data. So it's not only like RNNs are used only for sequential data; they can also be used for your non-sequential data. But the main use of this RNN is for your sequential data processing only. So for processing your non-sequential data, you are having other networks which are much more feasible, or which are not more complex than your RNN. So there is no limitation that it's only used for your sequential data. It can also be used for your non-sequential data processing also. Okay, so RNNs are designed to identify with sequential characteristics and predict the next likely scenario. So they are used in models that simulate the activity of neurons in the human brain, such as deep learning and machine learning. So similar to the working of your human brain, even this RNN can be used for many applications with respect to your deep learning and machine learning concepts. Okay, yeah. So, talking about some real world examples of how RNN can be applied. So, there are three ways or three scenarios on the real life which we can apply. That is varying inputs and fixed outputs. So, this is one important scenario which talks about the social media mining, that is your online data analysis. So, wherein you'll be having your social media like Facebook and Twitter or many other Instagram like things, where you'll be having a lot of reviews or a lot of comments being happening every now and then. So the main thing here is classifying these comments and segregating them into positive and negative comments. So there are some people who like to give only negative comments for anything and even everything, rather than helping us, as they have only one motive, that to push or pull somebody down. So assume that there are some employees who is working against Modi. So people who are not who don't like Modi will be continuously working on social media to tweet him negatively. So whenever Narendra Modi or somebody who is trying to tweet, so you can see many negative comments being coming, right? So there will be some people who will be trying to pull them down with their negative comments. So this we can identify such type of people using your recurrent neural network by using your sentiment analysis and text classification. So speech recognition, text recognition, and sentiment classification are the important applications which comes under these varying inputs and fixed outputs. Okay, so inputs with varying lengths while the output is of a fixed length. That's how this is one of the real life example you can apply your recurrent neural network, that is for sentiment classification using your positive and negative comments. And next one is about your fixed inputs and varying outputs. This is a bit opposite to the previous one. So here we talk about some image recognition where an image will be given, and your algorithm need to identify the contents of that image. Suppose assume that you have been given an image where children are playing in a park. So that image need to identify that image and give some sentence as the output. So it need to give the output saying that there are some students in the picture, those who are playing football, or somebody is riding a bike, somebody is riding a cycle, children are playing in the park. So there are some students or children dancing. So a image will be given of such type, and a output should be obtained like what are the sequential things a algorithm need to identify from the given input. Okay, so next one is varying outputs on varying inputs, right? So the main example for this one is your text translation. Suppose assume that you can take the best example of your Google online translation tool, where it can translate your given input into many languages. It can transfer to your Spanish or any other Hindi or Telugu languages. So according to your requirement, it will try to translate things. So assume that a human being is given such type of task to translate a sentence. He may take a lot of time because he might not know all the languages. He will look into a number of dictionaries and provide output. But a Google algorithm like a translator will be providing you the output on a click, right? So see how fast these networks are providing your output. So this tool is so powerful, which takes care of sentiments in each language, length and meanings with context. So this is the case of varying inputs as well as your varying outputs. So you all need to remember these examples with respect to your various types of applications for your recurrent neural networks. So we will go into the next use cases of your recurrent neural networks. So previously we have seen some real life examples, but there are some specified use cases with respect to different domains, how recurrent neural networks can be useful. The main application is your chatbots. You can see in many bank applications and many websites, chatbot is a very basic thing which is being used now, because an employee might not be available for 24 hours. If there is a chatbot, it can respond to some immediate instructions. So assume that I'm using a bank application. So instead of going to application and checking all the balance or some activities, I'll just request a chatbot to see to say that or to give me a response about my transactions about last month. So it will try to understand your query, and according to the query or the language whatever it understands, it will try to provide you output appropriately. So chatbot is one important application of your recurrent neural network, which continuously takes input from the previously available data, and accordingly it will be providing some output. Next, image recognition, as I said previously, to identify an image and provide some output. Next, music synthesis, machine translation, that is online textual translation, stock predictions, looking into the data of the previous day. You can predict stock data from using your recurrent neural networks. So these are some of the use cases which we can discuss with respect to your recurrent neural networks. Okay, so there are numerous exciting applications with respect to your recurrent neural networks, got a lot more easy, advanced and fun filled because of your RNNs. So because of the existence of RNNs, there are much many tasks which can be done in the upcoming years. So you can use your natural language processing to process your data and provide appropriate output also. Okay, yeah. So talking about these advantages of your RNN, so as you are having the concept of memory with respect to your recurrent neural networks, a RNN remembers each and every information with respect to time. It is useful in time series prediction or sequential data processing only because of the feature to remember previous inputs as well. So with respect to your stock predictions, it will try to store the information of the previous day's transaction with respect to time, and accordingly at what time you are getting stocks increased, and at what time, if you are providing some shares, you may get loss or profit, can be done using your recurrent neural networks. So this is called as long short term memory, which is a very important thing when we're talking about your recurrent neural networks. So long short term memory concept, yeah, we'll discuss about that in the next slide. So you need to remember about this long short term memory, which is a concept of your recurrent neural networks, which stores the information of the previous done transactions or the previous steps. So recurrent networks are even used with convolutional layers to extend the effective pixel neighborhood. So whenever you are having some image processing concept with respect to your convolutional networks, where you will be using your max pooling or any other layers of input layers of your processing. So recurrent RNN can also be used for your convolutional layers to extend the effective pixel neighborhood. So if you want to take some pixel from an image or identify some pixels with respect to convolutional networks, this can be much useful. Okay, yeah. So let's talk about this long short-term memory concept with respect to RNN. So kindly everybody need to remember about this. Even when in examinations, these questions can be asked. So like why what is the use of LSTM or long short-term memory in your RNN? So LSTM networks are a type of recurrent neural networks capable of learning order dependence in sequence predictions problem. So for every sequence data processing, so it is able to give you some appropriate output because of this LSTM. So this is a behavior required in complex problem domains like machine translation, speech recognition, and many other applications, whatever we have seen previously. So all these applications are able, RNN can be done because of this long short-term memory in the hidden layer only. So LSTMs are a complex area of deep learning. It can be hard to get your hands around what actually are these LSTMs and how terms like bidirectional and sequence to sequence relate the field. So I am not diving much into the concept of this long short term memory because of our syllabus constraints. So actually there are much more things which we can learn about this recurrent neural networks, but because our concept is only about basic introduction to your RNN, I am not getting more into these concepts. So long short-term memory networks are well suited to classifying, processing, and making predictions based on your time series data. For example, you can take stock market data predictions where you need some continuous predictions with respect to time. So since there can be lags of unknown duration between important events in a time series, so RNN networks can provide you appropriate output. Okay, yeah. So talking about the disadvantages of these recurrent neural networks, so gradient vanishing and exploding problems, which are the concepts which actually are the in-depth concept of your RNN. So whenever a network is processing some input data through a number of hidden layers, so there can be a problem of this gradient vanishing and exploding problems, which may lead to some misclassification or wrong outputs. So training a recurrent networks is a very difficult task because it need to remember the data in its hidden layer. A training is a very important step at this phase. So if you are not providing a proper training, that may lead you to some wrong outputs. So it cannot process very long sequences if using tanh or ReLU as an activation function. So even RNN also uses activation functions to process its information. So if you are using this tanh or ReLU as an activation function for sequential data, that may not provide you the appropriate output. Okay, so that's it guys about your recurrent neural networks. Okay.